Today we'll be talking about fantastic figures and where to find them. Hopefully by this point you have already downloaded Inkscape, at least version 1.0. We will be using that later on today. And also you can navigate to that GitHub link. There's going to be a very, very simple MATLAB script and a MATLAB SVG in a fig file that we will generate, and a stock photo that is also in a folder. Great. Feel free to interrupt at any point. I'm going to try to keep an eye on the chat. You can unmute, you can ask questions. This will be very casual, interactive, especially once we get into the hands-on demo side of things. We can go at whatever pace makes sense for the group. Cool. So I want to start out by talking about why good figures matter. So I don't claim to be the expert of good figures. In fact, I am still learning and I am perpetually unsatisfied with the quality of my figures. But here's just an example of two figures from my own research. So figure on the left is a figure that I presented in the qualifying exam that I now look back on with absolute horror. And on the right is actually the same content, so the same exact result, the same research outcome, visualized differently, and is now in publication. So the figure on the right, I think, looks much better. It is still not perfect. And in fact, making this presentation there, I noticed things that really frustrated me about it. So it's this constant process of evolution, right? But this goes to show that there's always room for improvement, and that even when we start out and we feel very confident about something, there are always ways to make our figures look nicer and hopefully move more towards the right and farther away from the figure on the left. This is important because our figures are going to be published, right? And unlike a research talk or a poster where someone will come, maybe they'll take some photos during the talk or the poster session, it's very transient, whereas papers are immortalized forever. So someone is going to hopefully download that paper 20 years from now, and they're going to be looking at those figures, and that'll be probably the first thing they see, the thing that they pay the most attention to. And so it makes sense that since you've been working so hard on your research and you've put in all of this effort to create, hopefully groundbreaking research, you want your figures to also reflect that, and you want to give them the opportunity to be immortalized beautifully. When your figures are beautiful, it makes your reader trust you more. And when your reader trusts you more, they trust your conclusions more. So if and this might not even be an intentional thing, this might be a subconscious thing, but when you see a figure with a typo or maybe a questionable color selection, you start questioning not just the figure, but the researcher that created the figure. And you think, okay, if there's a typo in the figure, maybe there was a bug in the code. And so maybe I can't trust their results as much as I would like to. Having trust in your paper results in more engagement with your work. So hopefully more citations, more opportunities for collaboration, more people asking you questions about it. That's the direction that we want to head to. And then this is a figure that I found recently that actually came from 2017. I'm not going to be dunking or commenting, critiquing figures that are not my own in this talk. This is the one exception, just because I thought this was such a fun figure with so much going on. A color scheme like the flag of Romania, this very word art 2005 style for injury. And my first instinct was, wow, that's a lot for a figure. And then the more time I spent looking at it, the more I realized that I actually like it, and that maybe the design of it is not what I would have picked, but it's quite clear to me as a biomechanist what's going on here, right? There's the structure, probably of a joint, the mechanics of the load that's applied to that joint, and the dosage, so how frequently that load is applied, will eventually bring someone past the threshold of injury and result in injury, right? Big rainbow letters, injury. The style, that's personal preference, but what a figure should convey is meaning. So there's, as you're listening to this presentation and you're hopefully absorbing some of the things that I'm talking about, you take everything with a grain of salt. Rules are meant to be broken. These are all just suggestions. They're things that I find impactful and aspects that create good figures, but it's all subjective. All figures are subjective. I'm going to start with something a little nerdier. So there's a word called semiotics. Semiotics is the study of signs, symbols, and meaning. So a sign in this context is something that communicates meaning or significance. So the example on the left, you're washing your hands. There are taps on the faucet, right? There's one that's colored red and one that's colored blue. You have a good understanding of what that means, that is a nonverbal indication. The blue tap is probably going to be cold. The red tap is going to be hot. If these signs or symbols are switched, you might get frustrated because you might feel concerned that I keep turning on the hot water and the water is just getting colder and colder. What's going on? You can think of that structure in the same way when you think about your figures, right? You want to introduce the reader to the conventions that you're using in your paper. And those conventions are the stylistic choices that you're making that you're going to be consistently using throughout your talk, your paper, your poster, maybe even more broadly in your thesis or your contribution to your research space. So an example of the semiotics of water faucets would be that red is hot and blue is cold. For scientific figure semiotics, right? What do dashed versus solid lines mean for your work? Maybe a solid line is the ground truth and the dashed line is a simulation, or maybe it's the opposite. What about transparency or transparent dots versus solid dots, right? Answer those questions for yourself. Make sure that you are staying consistent with those definitions throughout, and this will make sure that your reader or your viewer is not frustrated the same way that I would be if I went to the bathroom and I tried to turn on the hot water and it resulted in cold water. Or if two different sinks had two different structures for their color coding, I'd feel very frustrated. Have some respect for your reader and make sure that you are being consistent with your stylistic conventions. So now that we've got semiotics out of the way, we'll get into some figure essentials and some examples of some guidelines. A lot of these are going to be really obvious, I hope. There will be things that you will say, yeah, well done, Natalia. Obviously, I should make sure that my figure is readable. But you'll be surprised that when you add together all of these really simple rules, you get to like 95% of an excellent figure. And that remaining 5% is like a combination of creativity and originality and fine-tuning and incorporating opinions from like 20 different people, right? That's that last 5%. First 95% is making sure your figure is clear and clean and readable. So these are going to be dead simple, low-hanging fruit examples. The first one is image resolution. Again, this is low-hanging fruit, right? You want to make sure that when you are creating figures and then embedding them somewhere or sending them to a journal for submission, that you are exporting at a high resolution. A lot of times journals will have requirements for resolution. They will probably have a maximum requirement so that you're not sending them like one figure that is 20 gigabytes worth of image. That would be very hard for them to deal with. But export at the highest resolution possible. I'll get into the details of how to work with or how to export high res in Inkscape a little bit later. You'll also want to make sure that you're working with lossless formats. So PNG is fine. It will compress your image a little bit, but the method that it uses to compress is not super lossy. TIFF, I don't remember what these acronyms stand for actually. TIFF is going to be likely required for submissions, so for paper submissions. It is a lossless format, so it's there's no compression, there's no kind of resolution squeezing that's happening. SVG is support vector graphic. SVG is for vector illustration, so that's what we're going to be working with in Inkscape. And please never use JPEG. It is going to compress your images, your figures, make them very pixelated, very grainy, very ugly looking. It's probably not worth the time. There might be some cases in which you need to have a low resolution image. You're maybe embedding something very small and you don't have a lot of space, but generally never, ever use JPEG. And when it comes to taking photos, so if you have like a digital camera, I personally prefer to take photos in RAW and then convert them to either a PNG or some other kind of format. You can edit raw photos in a more robust way than you can after they have already been converted to another file format. You can have a lot more flexibility with things like exposure, lighting, saturation, contrast, but that's for photos. So that's a little separate from what we're talking about today. Here's an example of low resolution, high resolution. This should be pretty intuitive, right? The figure on the left is low resolution. So this was exported at 7.5 DPI, which is dots per inch. So that results in about 90 pixels wide. You can actually like almost count the pixels in that image, right? So this is a very, very low resolution image. The one on the right is at 75 dots per inch DPI with about 10 times more pixels. You can see even though the sizes of the image are the same, the resolutions are different, right? So size does not necessarily mean the same thing as resolution. Size on a screen and then file size, different things. Cool. Any questions on this or anything that I've talked about so far? Cool. Okay, next, low-hanging fruit, font size. Again, very straightforward. You want to make sure that what you are writing, the words that you are putting in your figures are readable. Sometimes easier said than done. So in a paper, your figure font should not be much smaller than the font size in your body text. And this is very different than opening up Inkscape, selecting 12-point font in your figure, because what happens is your figure gets sized or rescaled when it's placed in your paper. So you want to make sure that your font is readable when the figure is embedded in your document, right? Some figures are half width, some figures are full width. You want to make sure that your font is readable. If you have a font size in the body of like 12 points, then try not to go below 10 points. Anything smaller than that is going to be really hard to read. And you don't want people to have to break out their magnifying glass when they've printed out your paper and they're trying to read it, right? Hopefully people are moving away from printing papers and reading them on e-readers or on computers where you can zoom in a little bit more. But some people still print and we should make sure that our papers are readable for the ones who are printing. For posters, I think posters, this is a personal preference, posters should be readable at different levels of engagement. So a poster session is going to be really crowded most of the time, hopefully. There will be lots of people wanting to come look at your research, talk to you, look at your poster. There are going to be some people who are crammed up really close to the poster and they're looking at all of the fine details and they're reading all of your labels on your figures. And there's going to be people that are 3 people deep away looking at your poster who can maybe only see the title of your poster or the title of your figures, right? So make sure that you're creating a poster that can be readable at the different levels of engagement and that the content that you're providing them is interpretable at these different levels. For presentations, you'll usually need to increase the font size from what you created for example, a paper figure. You shouldn't just copy paste paper figures into your talk because it might not translate. You might want to keep the visual part the same, but scale up the font so that things are readable and so that people maybe all the way back in the lecture hall can still see what you're talking about. Obviously, this is also dependent on the size of your projector. There are rules of thumb. You can kind of look them up online. They have like suggestions for font sizes to use for presentations. Even the default settings in like PowerPoint or Keynote do a pretty good job. So again, making sure that your figures have a readable font size when they are actually embedded into the medium that you are presenting them in. At the bottom, I have a tip, which is save your figures in an editable format. Editable, not edible, editable format. The last thing you want to do is to have saved your image as like a PNG and then realize later that you want to have a bigger font size. And then you're going to have to do some weird photoshopping where you're overlaying a new text box over your old text box, making it bigger. Just save it as an editable file. So an SVG or even like a matlab.fig file. Then you can go back, you can make those small adjustments. You can make those tweaks if you're making a figure, you're adapting it for a presentation, for example. I think this is pretty intuitive for most people, but it took me a really long time to figure out that that is a much better way of working with figures than just saving like version 5, final 2, final. So that's a tip. Here's an example of font size. So maybe the figure on the left, the font is smaller. The figure itself is scaled maybe too small for a format like a presentation. The figure on the right, the font is larger and the figure itself is also scaled up. So the one on the right is obviously going to be more readable. Okay, this is my favorite part, talking about color choice. I think picking your paper palette is one of my favorite things to do when I'm writing. When it comes to picking colors, for some reason, muted or desaturated colors tend to appear more professional. Something very bright, very saturated, like a bright blue or a bright red, come off as unprofessional or childish sometimes. So more muted, desaturated colors tend to be better. When picking your colors, so this will be the color of your lines, the maybe elements that you're shading in. If you're creating illustration elements, what color are things labeled? If you have a device that you've built and you want to selectively highlight in a half opaque color some certain aspects of the device that you want people to pay attention to, what colors are you using, right? You should consider color vision deficiency. So about 1 in 12 men and 1 in 200 women have some form of color blindness. There's a chance that someone in this call right now has a form of color blindness. So there are browser extensions or websites that you can use where you can pull up a figure that you've created and you can see how that figure looks in different forms of color blindness, which is really cool. There are certain color schemes or combinations of colors that are better or worse for different types of color blindness. You can also consider that some people print papers, as I mentioned before, and some of them print in black and white. Make sure that your figure or your paper is still legible and interpretable when something's been printed in black and white. If you have 2 dark solid colors in a plot and you really need to differentiate between the 2 of them, consider using different textures. So making one dark solid, one dashed, maybe changing the hue or the saturation, the darkness of those colors to make sure that your figure is still interpretable. And then again, I recommend spending some time picking your color palette and then sticking to that color palette for the paper. So having a consistent reference for each one of the colors that you pick. So control subjects are always going to be dark navy. The basic condition with no haptic assistance is always going to be, dark green, and just stick with that premise the whole time. So even when you're labeling things, keep that same color consistent. I like the tool coolers.co, which I'll show on the next slide. It's a really nice way to pick a color palette. The figure on the right, so I got kind of deep into a Wikipedia rabbit hole preparing for this talk, thinking about color models. So there's like the full spectrum of visible colors, and then there's ways that you can simulate that color in computers, right? So there's RGB, which we're probably familiar with. This is the red, green, blue levels in an image. And then there's also CMYK, which is cyan, magenta, yellow, black. Those color models don't map to the same spaces in the visible spectrum. So if you're trying to translate between RGB and CMYK, sometimes those colors don't quite match and they don't overlap correctly. And there's also some models that are better at capturing certain shades or certain parts of this color domain. There's a really cool Wikipedia page on color models. People have been trying to figure out how to best model color spectra for many, many hundreds of years. Very cool, highly recommended. Coolers. Coolers is a very cool website. You can create color palettes just by pressing the space bar, and it'll randomly generate combinations of colors. This is a screenshot, so I can't show you how cool it works, but once you have some colors that you like, you can select an individual color. So say, I really like this color palette, but that orange is really annoying me. I can change just that one color. You can get a little bit deeper into it. You can change the saturation. You can say, okay, I want that orange to be a little bit more reddish. You can also try out, so just up here, if you can see my cursor, you can see these glasses. That allows you to simulate different types of color blindness. And then at the bottom, it gives you, I think that's not CMYK values. I don't remember what format that is, but that gives you values for color that you can then input into Inkscape, for example. So it's very cool. It's a fun tool. I like it a lot. It's also free. And there is a really excellent Twitter thread that I refer to a lot on color palettes. It's specifically for RStats, but all of the color palettes have open like either CMYK or RGB values, so you can pick out the colors that are used in those palettes. But there's just hundreds of examples, all different kinds of palettes. A lot of them are colorblind friendly and just a lot of fun to look at if you like colors like I do. Don't be afraid of color. Color is great. But be afraid of bad color. So here's an example of a figure where on the left-hand side are some poorly chosen colors and on the right are some slightly better chosen colors. So the figure on the left actually like physically pained me to create, but I just wanted to illustrate that even when the content is good and the content is consistent, you can really give your readers a headache by using colors inappropriately. So again, something more muted, desaturated can come off as more professional, and you can still get away with using different colors if you bring down that intensity a little bit. Great. Okay, a couple more comments. So ink to content ratio. So this is a ratio of your ink, which is all of your supporting material, to your content, which is the meat, the research results, right? You want to keep that ratio small. So you want to have as little ink as possible to as much content as possible. Ink here would mean things like boxes, lines, grids that outline your figure, unnecessary or redundant labels or text, bounding boxes around legends, little notches in the axes, the list goes on. The content is your hard work. So you want to put that first and foremost. You want that to be the thing that is carrying your figure forward. And you don't want to crowd it with too much ink around it. So here's an example. This is the same plot, the same content. It's a plot of how magic changes over time. As you can see, when it's a good day, I have a little bit more magic, and on a bad day, I have a little bit less magic. The plot on the left has the bounding boxes. It has the box around the legend. It's a little faint, but there's even a grid in the back, whereas the plot on the right, very similar. The legend has been shortened a little bit, so we've eliminated some redundant information. We've cut out some of the outlines on the box. There's a couple other things that we can do to clean this up further, but the plot on the right just seems a little bit more airy, a little bit more open, right? You can focus more on the content and be less overwhelmed by the outlines, by the ink. This is a way that I think about it. When I'm thinking about creating a figure, I want to maximize clarity and maximize consistency. So when it comes to consistency, right, you want to make sure you have that consistent color palette, that you've decided on your the meanings of each one of your colors, and that you're keeping it consistent throughout your document. You want to maintain a consistent font throughout, right? That'll also help signal professionalism. So you don't want to be mixing Comic Sans and Papyrus. That would be very silly. And then again, using those same signaling elements, using those same semiotic signals throughout the talk so that your reader only has to learn it once. So they're not relearning a new mapping every single time they see a new figure. And when it comes to clarity, make sure that you are clear in your communication of what you are hoping to convey to your reader. So I've never successfully used a pie chart in a visualization. I don't think it's impossible, but for some reason, I just don't find it to be the best visualization of data, right? I'm sure there is an example where a pie chart would be appropriate. There's lots of different kinds of charts. You have to pick the best one for what you are trying to convey. This is something that is permanently stuck in my head. But JJ, who's a researcher in Belgium, has his Twitter handle is show the dots on the plots. And he is always saying to show the dots on the plots when you are plotting averages. And now it's all I think about whenever I'm creating figures. If you have an average, unless you are showing like a violin plot where you have a really good understanding of the distribution, my meeting will end in 10 minutes. That seems silly. Contact your IT team to upgrade to Zoom Pro for unlimited group meeting minutes. What if we just rejoin using the same link? Will that work?